Today we are introducing automated embedding in vector search, a new way to build AI-powered semantic search where embedding generation is handled directly by MongoDB and not your application. Semantic search finds relevant results by understanding meaning behind the user's query rather than matching keywords, and uses embedding models to capture the semantic intent. Today, building the semantic search requires a lot of glue code, embedding pipelines, data processing, manual model API calls, retries, and scaling logic, all living outside the database. With auto embedding, MongoDB generates embeddings automatically during indexing, updates, and querying, bringing AI inference closer to the data. All you need to do is define an index with auto embed type. No embedding jobs, no background workers, just point to a field, choose a model, and MongoDB handles the rest. The queries are just as simple. Pass raw text into $vector search stage, and MongoDB embeds the query on the fly. This turns building an AI-powered semantic search with MongoDB into essentially a one-click experience. Under the hood, automated embedding is powered by Voyage AI state-of-the-art embedding models, delivering industry-leading retrieval performance. With multiple options, Voyage 4 Large, Voyage 4, Voyage 4 Lite, Voyage Core 3, teams can choose a right price performance profile for their use case. To get started with automated embedding in a self-management deployment, you'll need both MongoD and MongoT, the database and search daemons respectively. These can be deployed using Docker images, Linux binaries, or other supported options. You'll also need a Voyage API key available through MongoDB Atlas or directly from Voyage AI. Once the MongoDB community setup is complete, we can start exploring the data using a familiar tool like Compass. As you can see, this deployment comes with a few data sets, and to demonstrate semantic search, we'll be using the movies dataset. This dataset has information about movie and other aspects of it, like its plot, release date, etc. To enable semantic search, we will navigate to search indexes, and within vector search, create the index of type auto embed, which uses a Voyage model and focuses on plot field. Once we kickstart the index creation process, we can see the status change from pending to building, and in a short while we will see the index creation complete. So this was 21,000 documents and the index is complete there. To run the queries, we will put in a $vector search stage with a query text and request for top 10 results. So for this, we're looking at a fairy tale story, and as you can see, this is a classic fairy tale that comes up here. Let's add in more information here. Let's make it more richer. So the next query you want to look at is a fairy tale where someone falls in love. You can see some of the results change to have that intent of emotion and relationship, and not something that's happening purely on the keyword search. Let's take it a step ahead and ask for a setup where a fairy tale and monster falls in love. So as you can see, the result that's showing up, Beastly, is something that has non-human protagonist. Let's make it more interesting. Fairy tale where a monster falls in love and lives in a swamp. So as you can see, the intent is very clear here, and as you might expect, one of the all-time popular movies, Shrek, appears in the results. This is the power of semantic search with automated embedding in vector search MongoDB. You don't need exact keywords, just describe what you're looking for, and the system understands the natural language intent. And you can set it up in a jiffy. Thank you.